Second ICT4S Summer School. I'm Lorenz Hilty and I want to give you a brief introduction into ICT for sustainability. I'm going to answer 4 questions. What is ICT4S? Why is ICT4S needed? Is ICT4S focusing on footprints or handprints of ICT or both? And what are we doing in my research group? My definition of the research field ICT4S would be the following. ICT for sustainability is the interdisciplinary field in which the design, application, practice and impact of digital information and communication technologies are studied with regard to their potential contribution to sustainable development. But I see it also as a movement. People active in ICT4S usually share some motivation to use the power of the digital transformation to tackle the great challenges of sustainable development. These are the SDGs, the UN Sustainable Development Goals. We can always refer to the SDGs to define sustainability. I will not go into details here for the moment. But ICT4S is also a conference and a summer school. In 2013 we had the first conference under this name in Zurich. This conference was followed by one in Stockholm, and Copenhagen, Amsterdam, Toronto, Lappeenranta and virtually Bristol. And the next one will be in Plovdiv in 2022. You will find materials about all ICT4S conferences here on this link. This is a new website Patricia Lago has created to provide everything at one place. There are related fields. So some people ask what is green IT or ICT? Is this the same as ICT4S? There is also the term greener data centers or green data centers. There is green information systems. There is sustainable HCI, SHCI. For a long time there has been a field called environmental informatics. There is also computational sustainability and of course ICT for sustainable development. I think we will have a special presentation on that as well. So if you are interested in the connections between these fields, you can also read this in my paper from 2015, which you find behind this tiny URL. Some people also ask what is ICT at all? Yes, this is because today many people say just technology when they mean digital information and communication technology. And so they don't understand why there is a term like ICT. But I consider this use of the word technology not a good idea, because also fire making is a technology, or sailing, or building a piano, or a steam machine, or genome editing, space shuttles. These are also are technologies. So it is definable what the specific technology of ICT is, and here I'm trying to give you a precise answer. So historically there were 3 separate lines of technological development that were connected to information. And they only recently merged into today's digital ICT. So these technologies or technological lines of development were technologies to transmit information, to store information and to process information. They were sometimes digital, sometimes analog, sometimes mechanical, sometimes electromechanical or chemical, whatsoever. So the special thing that happened in history now, in very young history, is that all these types of technologies converged into one substrate, one physical substrate, which is digital electronics. And this made this convergence or even confluence of these three types of technologies possible. And especially also the programmable components that are always there in digital electronics. And this has the consequence that everything that is today transmitted must also be stored. Everything that is stored can also be processed and transmitted, and vice versa. So this whole confluence or convergence made it possible that the internet emerged, and that today 5 billion people have access to the internet. So more than 60% of the world population. So we are talking actually about transformational power and how it is used. So it is this confluence that makes the digital ICT such a powerful tool, and we should really try to use this power to harness it for sustainable development. I forgot to click these red circles here. So this is all ended up in digital electronics. So the central question, finally, of ICT4S to me is: how is the transformational power of digital ICT related to the possibility or impossibility for human society to get on a sustainable development path? So I maybe over-answered the first question a little bit. Second question: why is ICT4S needed? Look at this. The world is still a bit divided between tech nerds and tree huggers. This divide no longer follows gender lines as it used to be, so this has improved a bit, but nevertheless it is essential that these two groups, the technological enthusiasts and the people interested in preserving this planet, that these two groups talk to each other. This is really, really essential. And also the corresponding academic disciplines must collaborate. So ICT4S is actually intended to build such bridges. We need the technological enthusiasts to unleash the transformational power of ICT for solving real-world problems. And on the other hand, we need the sustainability goals, we need the awareness of the planetary boundaries to give the digital transformation a meaning, as opposed to just doing everything faster, no matter what. So, ICT4S calls for inter- and transdisciplinary approaches. From the ICT world, we typically need experts in information systems, in software engineering, in HCI, in computer architecture, in modeling and simulation. And from the other disciplines, we need many experts, domain experts, for example, from environmental sciences, from social sciences, from parts of philosophy, and we need stakeholders from practice. So ICT4S is actually needed as a place where these bridges are built. So, third question: is ICT4S focusing on footprints or handprints or both? These are examples of footprint issues, and specifically carbon footprint issues. You may have heard of this discussion about streaming, how much CO2 is created by streaming, etc. Or also the discussion about the footprint of AI model training with these tensor processors. So these are footprint issues. But there is, of course, more to say about ICT and sustainability than carbon footprints. I would like to show what I mean by footprint and handprint using this conceptual framework. Footprint is a metaphor that addresses only a part of the impact of a technology, namely this part here. When we are talking about the footprint of ICT, we are adopting a life cycle perspective and life cycle assessment methodology, because we are looking at the life cycle of the hardware, maybe even of the software, and their consequences for the environment. And this is really useful, yes, but there is also such a thing like the intended effect of applying a technology, which in LCA is reduced to a functional unit in life cycle assessment. But in this framework we have substitution and optimization effects. We have in the long run new patterns of production and consumption as a potential impact of ICT. And we even have things that are not included in the footprint or the handprint metaphor either. I will not go into detail now in this talk. You can also read about this conceptual framework again in the paper I already mentioned, again with the tiny URL here. It is, by the way, not the only existing, of course, and it's certainly not the best one. It just emerged years ago as an attempt to integrate several pre-existing terminologies to structure ICT impacts. Sometimes people also ask me, what is the problem? Because the columns are called ICT as part of the problem, ICT as part of the solution. This is a fair question, of course. What is the problem? Yes. So in my view, the problem addressed here implicitly is the fact that society is not really successful in transforming itself towards a more sustainable process. When we only focus on the footprint for a moment, ICT looks extremely efficient. The computing power you get per kilogram microchip increased by an incredible factor of 100 million, a factor of 100 million in 50 years. So for 1 kilo chips you get 100 million times more computing power than you got when the first one-chip microprocessors were built in the 70s. If we can learn one thing from the ICT sector, it is the following. Increasing efficiency alone does not reduce the overall footprint. This is explained economically by the rebound effect, or Jevons paradox, if you like. If there would be no rebound effect in the world, we would almost need no space, no material, no energy to do computing today. Let me explain how this works with a little example. We did a recent study on mobile networks in Switzerland, the time horizon of 2020 to 2030, and we had two main results. The result number one was that the 5G network in 2020 will need less energy per gigabyte by a factor of 7 compared to the existing hybrid network. So this is true even if we include the impacts of producing and installing the infrastructure. So we included the life cycle into this footprint calculation, or into this energy efficiency calculation in this case. And of course also the use phase energy. So a factor of 7 improvement in energy efficiency. So you could in principle, in an ideal world, you could expect that then the mobile network would use in Switzerland only 1/7 of the energy. So we would save energy. But the result too was that the network this efficient network is planned already now. It is planned for a data traffic increasing by a factor of 8 compared to today. That means that if this network will be economically successful, the energy consumption of the mobile network will have to increase in total. And it is even the case that the efficiency would not be realized if we would have a lower utilization. So this is maybe even more than a rebound effect. This is sort of a planned, a deterministic rebound effect. It's not a market emerging whatsoever surprise. It's already there. It's already now. And this is a pattern we find everywhere in the ICT world. By the way, if you are interested in the whole methodological discussion about the ICT carbon footprint specifically, then I can recommend you this report, which is quite new, by Laura Marks and colleagues from Simon Fraser University, Vancouver. And I found it really comprehensive and thoughtful. The title looks as if it would only focus on streaming media, but in order to solve the problem of the assessment of streaming media energy, the authors are in fact redigesting all the whole discussion about the ICT carbon footprint. So it's really something of the most comprehensive reports I have seen. So, but let's now also look at some handprint examples. So, handprint example number 1, precision farming. We have today already, we have such solar-powered weed robots that can save 90% of herbicides compared to the normal method to just to throw everything everywhere, because they can differentiate. They have vision. They can see what plant they like and what plants they don't like, and at least this saves then 90% of the herbicides. It also avoids heavy load on the soil because you don't need so heavy machines. They are very light. And they are slow, and they are powered with solar energy, so you don't even need fossil fuels to let them work. So these are some ideas which I think require more attention, also to maybe to avoid some sort of rebound effect that would also already be around the corner, or some monopolistic structures as everywhere. So it certainly takes some care of how to deal with this, with the power of this technology, but it has a potential to create a better agriculture in the future. The same I would say about recycling robots. Of course, today these examples from Apple, Daisy, etc., who do dismantle some smartphones are maybe not the most relevant thing quantitatively at the moment. Of course, the smartphones are important, but I think we should think beyond the ICT itself when we think of good recycling, because we have some material flows that are much larger and much more important even than the e-waste flow, although the e-waste flow is part of a very bad footprint of the ICT. That's clear. But if we think, for example, of building construction materials that can be recycled, there is already a very successful company called Zen Robotics from Finland. And these robots can sort demolished buildings actually, which creates a lot of new and useful materials. and also household waste could be recycled better in the future. Now there is people often object with this argument that recycling always costs energy. That's correct, but primary production of materials also costs a lot of energy. And second, imagine that there is such an army of recycling robots that only wakes up when there is more renewable energy available than is currently used. So when the sun shines and the wind blows, etc. And then they could use this energy instead of storing them to sort materials. So I see intelligent recycling as a form of indirect energy storage, and we need energy storage. Okay, just as a vision or inspiration for handprints of future ICT. So, what are we doing in my research group? Just a very brief introduction of my group. Jan Wieser, he finished his PhD about the impact of digital transformation on traffic, time and energy use, and is still working on these topics also at KTH Stockholm and in close cooperation with our wonderful colleagues in Stockholm. Second, Matthias Huss, who mainly works on projects in Tanzania to investigate what information could help small farmers to reduce food insecurities. This also connects to issues of food speculation in some way. Then we have my PhD student Maria Puri, who works on develops a method for assessing the sustainability of sharing economy platforms and digital sharing business models. And finally, Joao and Marta, who are developing a serious game, the Post-Fossil Cities game, which lets the players interact and explore pathways into a post-fossil future of Swiss cities. This project is part of the Swiss National Research Program Sustainable Economy. So this was all for the moment. Thank you very much for your attention, and I'm looking forward to seeing you live and virtual in the summer school. See you.